Okay. So it looks pretty complex, okay? But here's basically what they're saying, and this is actually back from chapter 2. That if we would do like long division and divide these two fractions, what we would get is we'd get the answer, and then we learned that we could write the remainder as a fraction. Do you kind of sort of remember doing that? Okay. And so the rules of partial fraction decomposition is we're going to factor that dx into a product of factors of the form mx plus n to the u. That just means mx plus n to the u just means that we're just going to factor it into linear factors. For each factor, what I have to do is make sure that I have a different fraction for each of the factors, okay? And let's keep in mind here, I'm going to try to do one at the end, that if I give you x cubed, what things factor or are factors of x cubed? Well, one of them would be x cubed, correct? What else goes into x cubed? X squared and x. So if you see an x cubed up there, you are going to have to list fractions for not just x cubed, but anything that factors into it. Okay, so I'm just showing you this as an example, okay, not to find the partial fractions, but if I was looking at this example right here, okay, do you see it's already in factored form? Do you see how one of them was x cubed? The other is x plus 3, and the other is x squared plus 1. So look across the page. Do you see the first thing they did is they wrote 3 separate ones for x cubed? A over x, I know you can see it on the next page, right? A2 over x2 and a to the third, A3 over x cubed. Then they wrote another one for x plus 3, and then another one for x squared plus 1. We're going to find the first two types. We're not going to get into what if there's a factor of x squared plus 1 and find it, because what ends up happening then is they're not just constants, they end up having like an x in them as well. And we don't have time to do that in this class. Partial fractions is something you would use when you do calculus, so we do have to do some kind of introduction to it. Alright, so we can at least, though, for an example, I'm not going to go through finding them quite yet, but what if I asked you to write the terms of the partial fraction decomposition of, let's do this one. Okay. So what we would do is first we take this x squared, okay? The things that go into x squared are what? X and x squared. So that would be two of my factors. Those ones I would just write with maybe an A and a B. And what A and B mean are A and B are just going to be some number. Like maybe it's going to be a 5 and a 6. Bless you. Oh, goodness. All right, what's the last factor you see there? X squared plus x plus 1. And so that would be my last one, x squared plus x plus 1. And when I see something like this, and this is the one that you should know what to write for the denominator, but we're not going to actually ever find them, is this would have to have a cx plus d on top because it's a quadratic, x squared plus x plus 1. So basically, that's the setup for finding the partial fraction decomposition. So we factor something that's a singlet, x and x squared, and then anything that's an x squared plus x plus something, you write using a linear factor on top. Okay, let's actually go through the process of doing one that's simpler than that. This time we're going to actually not just find the terms, we're going to find the whole partial fraction. Decomposition. And let's do x plus 22 over x plus 4 times x minus 2. I already factored it for you. Okay, so the first thing is what we're going to do is we're going to write it how we just did earlier. The bottom is already factored. If it isn't already factored, then we just factor it. So what are the denominators of the partial fractions going to be? Yep, so I'm going to just put an A. A represents what I'm going to find that number. A over x plus 4 and B over x minus 2. And you might say, well, what if I had listed the x minus 2 first? That's fine. At the end, your A and B would just be switched from what I got, but they would still be the correct fraction. Okay, so once we do that, what we try to do then is figure out some kind of an equation, and this is where we're going to use a matrix if we need to solve it. So I know that these two fractions add up to this. So I'm going to try to write an equation with A and B. So I'm going to do it the same way we did in the opener. If I were to put A over x plus 4 plus B over x minus 2 together, what would I need to do? Yeah. Okay. So what I'm going to do then is I am going to multiply this one by x minus 2, right? And this one by x plus 4. And I'm not going to bother multiplying out the bottom, okay? Because on the bottom, we know that it's going to multiply to be x plus 4 times x minus 2, and that's what we want. But let's multiply the top. What would the top expression give me? Yeah, we're going to have A's in it, so let's distribute the A. So I'd have AX minus 2A, agreed? And then what about with the B? Plus BX plus 4B. Okay. Now, keep in mind, we are trying to figure out what A and B are so that they equal what on the other side? X plus 22. Okay, now, let's just make sure we understand, over here we have an x and we have a 22. By the way, what's in front of x? 1. Okay. So right now I'm just going to ignore the denominators for a second because our denominator is the same. I'm just going to look at the top. So what I'm going to do is since I have an x and a constant, I'm going to over here try to get the x things together and the other stuff together. What terms have an x in them? A and B. So if I were adding these, I could write that as A plus B x. What's the other stuff? What's left? Minus 2A plus 4B. So here's where we are going to write our system of equations. What did you say is in front of x here? A plus B. What's in front of x there? 1. I need them to be equal. What does that mean? If what's in front of x here? A plus B. What's in front of x here? 1. Tell me an equation with A and B. A plus B has to equal 1. Okay, now, What's left over here? 22. What's left over here? Minus 2a plus 4b. So then I'm going to write minus 2a plus 4b equals 22. Okay. Once you get to this point, I do not care how you solve that. If you want to put it in a matrix and do RF, even though it's a 2 by 3, that's fine. If you think it's faster because it's only 2 variables to just multiply the top by 2 and add and find, that's fine too. I do not care your method of solving. What do you want to do? Should we just multiply the top by 2? Is that quicker than having to put it in our calculator? Okay, let's do that. Multiply the top equation by 2. What would we get? 2a plus 2b equals 1? 2, sorry. If I multiply that top equation, here I am. If I multiply that top equation by 2, I get 2a plus 2b equals 2. And then my second equation was minus 2a plus 4b equals 22. All right, would you find b and a for me, please? Now that I got you that far. Is that what you got? Okay, so going back, B, and I have to flip my page, so I'll just let you flip your page back. B was over which factor? What was the x minus 2? Okay, so my fraction decomposition would be 4 over x minus 2 plus, and then A was over. So if you would go through the process of adding those two fractions together, you would get x plus 22 over, what was it? X minus 2 times x plus 4. Okay. Let's do one more so we can get the process down. Alright, first, would you guys, if I have 5x minus 1 over x squared minus 2x minus 15, let's factor the denominator. Let's see, that would be x minus 5x plus 3, correct? So, write two fractions for me then. What would in general? A over x minus 5. Very good. Alright. Now, let's go through. What are we going to do to this one? Multiply by x plus 3. Multiply by x minus 5. Now, we should already know what the bottom equals because that we purposely factored it, right? So distributing, I get AX plus 3A plus BX minus 5B. Okay. Now I'm going to ignore the denominators for a little bit because I just want to find out what A and B to make the numerator correct. So I want to look at what I have here, and I have things with x's in them and things with other things in them, just constants. So I'm going to group the x's again. I have AX plus BX, so I can write that as A plus BX, and then what's left? Plus 3A minus 5B. So I take what's in front of x here, and I look what's in front of x here, and I write an equation. So what could I write? Good. A plus B equals 5. And then I see I have some stuff left, and I set it equal to the constant term. So 3A minus 5B equals -1. All right. At this point, you can do what you want to solve. I'm going to just go by hand. If you want to plug it in your calculator, you can. I'm going to just multiply the top row by, I'll do -3. Okay, I get that B equals 2. So going back to up here, B was over x plus 3. So one of my fractions is going to be 2 over x plus 3. And I'm going to go back to the simplest form. If A plus B equaled 5, what does A have to equal? 3. And 3 was, so A is 3, and that's going to go over my x minus 5.